Hello. In this lecture, we're going to talk about variables and data structures, and specifically in Python. Here's an overview of everything we're going to go over in this lecture. We're going to do an introduction to the Git version control tool. We'll do a compare and contrast because people often get this is difficult to say, often get Git confused with GitHub. So we're going to do a compare and contrast of the differences between the two. We'll look at variables, what they are, how they're used, and then we'll look into lists, dictionaries, which more focuses on key value pairs for our software objects, tuples, which are unchangeable. You can't change them. Once you set them, they're set. And each of these are data structures that we're going to be covering, and they're defined in certain ways. We're going to cover Postman environments, how they're used, and how we can use them to store our variables. I'm going to introduce you to the Cisco DNA Center always-on sandbox available on the internet. The Deck of Cards API, which is a great tool to practice coding, scripting, and testing it against a real API. We'll do a quick demo, and finally we'll move into our summary. You're going to go over an introduction to Git. So what is Git? Git is a version control system in its most high-level definition. But what it's really used for is tracking changes made to software. So it's a command line interface that you use, and it tracks the different changes that people make. It also allows you to host your code and software in certain places on the internet so that other people can contribute to it, use it, and that's what kind of makes something open source. We're going to do a lot of cloning of code repositories in here, which once you do it, you'll start to get more and more familiar with it, where it's making a copy of a repository that's hosted somewhere. It's used to track changes to the code, so when you make changes to the code, you have to use Git to commit those changes after you've tested them yourself or think that they're good to go. And then you actually push it to your repository for review and implementation into production. It allows you to collaborate with other developers so that we can have things like open source tools and open source software, so people, just out of the goodness of their hearts or to practice coding or to get on the list of people that contributed to the code, they will often use GitHub to contribute to open source software. It also allows for a historical view of the code, who did what changes they made, and then you can roll back to any of those different changes. So it really answers the question of who did what, especially when something breaks. Here I'm on the Ubuntu SDN VM, and I'm going to list the contents of my directory and see where I'm at with the present working directory. As you can see, I really only have the basic directories that would be in an Ubuntu operating system. I'm in the SDN students home directory, and I'm going to run a git clone command and paste in the URI for the module2 lab. As you can see, it cloned the repository. If I run my list command again, I now have an SDN module2 directory. If I run a git status from right here, it fails because I'm not in a directory with any git hidden files or folders. You can see they're just not there. I've got git config, but that is the configuration directory. And you'll see the difference. I'm going to clear my screen, and I'm going to go into the SDN module2. Run a git status, and here you can see now it says I am on the master branch and I'm up to date with the origin master, which is the GitHub repository. If I do the list command and use the flag for long and all, you'll see I have a .git directory which is hidden. So I'm going to list the contents of that directory, and here you can see I've got things such as configuration, branches, description, the logs, and a couple of other things. But this is really what happens when you initialize a Git repository, is you create that Git hidden directory, and it automatically puts everything in here for you. I'm going to clear again, because if I run a regular list, you will see I do not see that. But here's everything that is in the Module 2 lab folder. So I'm going to go ahead and create a Python virtual environment by specifying the module flag, then for the virtual environment module, and I'm going to call it joke. I'm now going to activate my virtual environment, and you can see I am now activated. Using pip, I'm going to install. Actually, before I install it, I'm going to review the requirements folder, and you can see it basically looks like I just have requests that was in there and all the dependencies of requests. So now I'm going to go ahead and run pip install, specify the R flag because I'm using the requirements.txt file to install all of my Python packages for this module. And there you can see it parses over the requirements.txt file and installs everything that's needed. So if I run a git status again, you can see joke has now been altered, or the repository has been altered with the joke directory that was used when I created my virtual environment. When I'm done working, I'm going to want to delete my virtual environment because I do not want to include that or upload it to the GitHub repository. Plus, you can see how easy it is to install and delete virtual environments, as well as installing via a requirements file to get them up and running with the correct packages. So now I'm going to go ahead and create a branch, and I'm going to use that with the command git branch, and I'm going to call the branch Sheldon. Now I'm going to run my git status command again, and you can see I'm still on the master branch. So I'm going to switch branches with the git checkout command. And as you can see, it gave me a message switched to branch Sheldon. It is important to read what the terminal is telling you, because if you have errors, chances are it's going to tell you what your error is. So now that I have my requirements.txt file installed and I'm on my working branch, let's go ahead and run the joke Python script. The grass is always greener on the other side unless Chuck Norris has been there. In that case, the grass is most likely soaked in blood and tears. It is Chuck Norris. So now I'm going to run my git status command, and you will see I still only have my joke, but it does let me know I'm on the branch Sheldon. So now I'm going to modify the joke.py script. I'm going to use nano, which is just a command line text editor. It's fairly easy to use, especially for beginners, because it gives you the menu at the bottom. So when I execute nano joke.py, as you can see, it launches nano, and I can now move around and edit the file. So I'm going to add a print statement in here to print, hope you enjoyed your Chuck Norris joke. And you can see down at the bottom, like I said, it gives you a menu so that you have something to reference. So I'm going to write the file out, which means save, and it's going to ask, did you want to save it as joke.py? I hit enter because yes, I do. And now I'm going to hit Control X to exit. And I'm going to execute the py script again. And you can see now it lets me know that I have my hope you enjoyed your Chuck Norris joke printed to the screen. If I run a git status command, it's going to let me know that my code has now changed or been modified. So you can see joke.py has been modified right here, and it gives you even a few options on where to go from here. Right now my Python virtual environment is untracked, and I want to keep it that way. But I have changed my joke.py file, and I want to make sure that now I've tested it and it works properly by displaying the message to this end user after the joke actually runs. So I want to keep that and push it. So I'm going to go ahead and do a git, just like it says, add, and I can do joke.py to do just one because I only have one here. I'm going to go ahead and do joke add and do a simple period which says add everything that is in this directory. Actually, I'm not going to do that because it would take my my joke directory with, which is not what I want. But this is how you would do that, and just know that it is possible. Or we could, to demonstrate that, how about I deactivate my Python virtual environment. I verified that the code has worked, so let's say I'm done working, git status now lets me know. So I'm going to do a remove recursive and force on the joke directory, which is going to delete my virtual environment. If I do a list, I can see that the joke directory is now gone. If I do a git status, that directory is now gone as far as an untracked file. So now let's use git add and use a period to add all of the files that we have changed. And this is going to add them to our staging area. So this does not push it quite yet or commit it to the branch even. It is just staging it for a commit. So I'm going to add it. And if I do a git status again, you can see it's changed. I could restore from that, but since I know it works, I'm going to go ahead and do a git commit. And I'm going to add the message added friendly message after joke. And that's going to be the message that appears in my commit. I have already signed into this Git environment, so it already is letting you know that that's okay. Normally this would produce an error if you have not configured it with your username quite yet, because the git commit is actually going to tell everybody who the user was that actually made these changes. So now if I do a git log, you can see the different changes that have happened, and it gives a commit with what's called a commit hash. And you use the commit hash as an identifier for the code at this point in time. So if I use the git diff command for difference, I could compare any one of these pieces to any one of the other ones using its hash. So although this is the same code, it has been modified in each one of these. So if I wanted to see the difference between this commit space this commit, and I hit enter, it is giving me everything that has changed from those two commits. That is a lot because that was the first and the last one. So let's do a git log again to grab our hashes. And then I'm going to do a git diff. And again, you only need the first few characters, so I'll just go ahead and type them in. 8.5, and then I will do A892F9, which is where the code was before we added the message. And here you can see from this hash to this hash, it has removed the print statement because I checked this one against that one. And in this one, that is not there. If I wanted to see it the other way around, I could do that as well, just by running the hash the other way around. And there you can see it was added because we looked at it in a comparison from this version to that version. Git versus GitHub. Git is the actual tool. It's a command line interface that we're going to use. So with it being a command line interface, it is just another command line tool with options and various things you can use it for. It's also built into some code editors that we'll see later on in the course, which will give you that graphical user interface to do the basic functions of Git. When you create a code repository using Git, you create a hidden configuration file known as the .git file, which you can see with a list command specifying list all because it's hidden, and inside of that directory you're going to have various configuration files such as where the repository came from, your username, your password, your information for when you make changes to code and commit them with a commit message. GitHub is the repository. It's actually what hosts your code. So some people kind of think of it as a cloud-based feature where you use a cloud to store things. You use a code repository on the internet to store in specifically code, so it has some various tools and features. And there is a link to GitHub in this week's module. It's on the internet, but you can also make a GitHub or a Bitbucket repository local inside of your own local environment. If you do that, just keep in mind that you've got to update your configuration file to point to your local GitHub repository, otherwise it defaults to GitHub. And it allows you to collaborate globally with other developers. Some alternatives to GitHub, which are still code repositories serving the same function, just different platforms, is Bitbucket and GitLab. Here we have GitHub, which is on the internet, and it's free to create a profile. So if you have not done so already, please navigate over to GitHub at github.com and create yourself a free profile. This is my repository for the Module 2 lab. So you can see the URL up here, which identifies where it actually is. So it's at github.com, my username, and then the name of the repository. This is the master branch of the repository, and here I can see all of my files that I have for this module, including the README, and then I've got my auth.py script, and my joke.py script, as well as my requirements file, because when you clone the repository, you're going to clone the requirements text file along with it, which makes it so that anyone who clones your repository and wants to run your code knows what they need to install in order to actually run your code. It's here that we can actually look at multiple branches, but because this is the first lab that you have with Git, I do not ask you to push anything up to my repository. But the basic idea behind it is I clone this repository, I create a separate branch that I can work on, which would be my working branch. Once I've finished and tested my code, I can then push my branch back to the code repository where the owner could look over my changes and commit them to the master branch. If something changes, it makes it easy for us to roll back because we will have the historical views of what changed in our code. Over here, you can see we've got clone with HTTPS, and this uses Git, so that I can just copy my URL right here, paste it into my git clone command, and it'll download this repository. It also has the options to download it as a zip file or with the GitHub desktop app for Windows. Variables. What is a variable? Well, you're going to hear the term variable more and more in IT as you progress throughout your career. Really, a variable is something assigned to something in its most, I would say, high-level view. But this something can be changed, so it's a value mapped to another value, or a object mapped to another value, a string keyed to something. But it is an object. You define a variable with the equal sign, which we'll see in a demonstration here shortly. A variable can be a string, which would be a text message or something in written letter. It can be an integer, which would be a whole number, a float, which would be a decimal number, or you can even have Boolean variables which are true or false given a certain condition. Creating variables in Python is actually pretty easy, so I'm going to go ahead and demo this by going into my Python 3 interpreter, and I'll just call my first variable, I don't know, device1 equals router1, and code equals 7.1 because that's our code version, and we could do the device model equals 3850, and for our final one we'll do status is true. Now, if I run the type function against my device1 variable, you can see it lets me know that it is a string, indicating that it is a text string. If I run the type function against the code version, it's letting me know that it is a float because it is a decimal number. Type against device model produces an integer because it's a number, and type against status is BOOL because it's a Boolean. A Boolean can be true or it can be false. And that's really all there is to declaring a variable. You can assign variables multiple values. Whatever it is that you want the variable name to be, you can make it that. So if I quit out of here, I quit out, and I'm going to go ahead and clear my screen and go back into my Python 3 interpreter, and I'll print code. You'll see it errors out, and this is because everything that has been removed from memory because I got out of my Python 3 interpreter. Lists. A list is a list of objects. So these can be variables, they can be dictionaries, they can be other lists, but it is a list of objects. Lists in Python are identified with square brackets, which define the list, and objects in the list are separated by commas. Lists are dynamic, in which you can add or remove, even update objects, and they are numbered 0 on up as you parse through the list for specific information. And here's a simple example of a list. You can see it's defined with square brackets, and we have object 1, object 2, 3, and 4 in the list, all separated by commas. A list in Python is simply that. It is a list of objects. So I'm going to define my list by calling it devices. And lists are started with these square brackets. So devices, I'll do router 1, router 2, switch 1, and switch 2. And I'll end it with another square bracket. Now if I print devices, it prints out the whole list. If I call the type function and run it against devices, it lets me know that it's a list. Lists are numbered 0 on up, starting with the first item, the first object, being at place number 0. So this would be place number 0, 1, 2, and 3. We can call each individual object by its placeholder. So if I did a print devices, and then I'm going to do a square bracket, and I'm going to call device 0. And you'll see it just prints router 1. I can append devices to the list. So devices dot, and then I'll call the append function, and I'll pass it a value. For instance, firewall 1. Now if I print devices, you'll see that we now have firewall added to our list. If I wanted to remove an item, I could do delete devices, and let's do number 0. Now if I print my devices list, you'll see router 1 is now gone. Now append adds it to the end, but let's say I made a mistake and I wanted to add router 1 back in. So then I could do a devices dot and call the insert function. I'm going to say at place 0, I would like to place router 1. If I print devices again, you'll see router 1 is back. I can run the length function against my list devices, and that'll tell me how many objects there are in my list, in which this case I have 5. I can assign the length to a variable. I could say device count equals length devices. Now if I print device count, it is a 5, and my type lets me know that it's an integer. So let's add one more device real quick, and we will do that with a devices.append. We'll do firewall 2. Now let's print device count again, and you'll see that it's still a 5. Even if I run the length function against my devices, you'll see it's now a 6. This is because I declared the variable up here and it's running in sequential order. So if I wanted to update the variable, I can do so. By just calling it again. Now if I print device count, you can see it's now a 6. So I'm going to quit that and clear my screen, and that ends the introduction to lists with Python. Dictionaries. Dictionaries are another way for us to form or structure our data. The difference is they use key-value pairs where the key is mapped to a specific value, allowing you to call the key as opposed to a list where you would have to call the number. They're defined by curly brackets. Keys require quotes. They are separated by commas. Also, dictionaries can be dynamic. You can add key and values. You can update a key with another value. And here's an example where we have a dictionary of 3 different objects. Key 1, which is mapped to value 1. Key 2, mapped to value 2. And key 3, mapped to value 3. For the demonstration on dictionaries, I went ahead and just created 3 different dictionaries, one labeled gig 1, 2, and 3. You'll notice that they're defined with these curly brackets, which indicate that it's a dictionary, and dictionaries actually are the exact same syntax as JSON. So it works with these key value pairs, where here I've got the key of mode with a value of trunk, which is a string. Here I have speed of 1,000 as an integer, and enabled is true. I've also created 2 lists with all 3 of our dictionaries in there. This one is the correct one. This one is going to actually put all of the information from all 3 of our dictionaries into our list of dictionaries. This one is simply just a list of 3 strings, but I did think it was important to kind of point that out and just show you how granular you have to be with your syntax on this. So if I do a type against gig 1, you'll see it comes back as a dictionary. A type against interfaces comes back as a list. Well, let's see what happens when I print gig 1. You'll see I get all that information. And now if I print interfaces, you'll see it gives me all of our devices and all of the information. But if I just do a print on my interfaces, you'll see it just prints gig 1, 2, and 3 because those are all just strings. And I could verify that with a type my interfaces and then just calling one of the objects. And there it says it's a string. If I type for interfaces, you'll see it lets me know that's a dictionary. So there you can kind of see the power, why that type function comes in handy so many times. But a list of dictionaries is something you're going to see quite often, and this is actually a very good real-world example, although I manually created these 3, and these are in JSON format. But you'll commonly get a list of interfaces back in JSON format, and it'll be this is how you would get it back if you were doing API calls. So what if I wanted to pull out or change just the speed? Or I wanted to pull out or change whether it's up or down. So in order to do that, we're just going to use our print statement for testing. But I would have to call which one it is that I want, so I would say 0. And then I also have to call the key. And here we'll go ahead and do speed. Close that off. So I've called a specific object, which would be the first object in our list, and then I'm asking for the key of speed. And there it gives me 1000. If I wanted to add another value to a dictionary, I can do that as well with a gig 1, and then I throw in, let's add a description to gig 1. And we'll call this link to LAN. Now let's print gig 1 again. And you'll see now we have a description. But if I print interfaces and call the first object, which is gig 1, you'll see I also have description link to LAN. Because the list is referencing this information. So although it was down here in the script, because we updated this dictionary object, and this references that, it points directly to that name, it was automatically updated as well. So this is a very common use case scenario where you'll actually see that, and you've got to pull out and work with specific keys out of specific objects. Typically, you're going to have a list which is going to be objects that are similar, so they're all going to have the same key. And this concludes Python dictionaries. Tuples are similar to lists, but the difference is tuples are not dynamic. Once you code them, they are hard-coded into the software, so you cannot change them. Tuples are defined by parentheses, and like lists, they're separated by commas. And here you can see we have a tuple of object 1, 2, and 3, separated by commas, identified by parentheses. Tuples are actually very similar to lists. So I'm going to go ahead and define a tuple as devices. And one of the differences is in the syntax there with parentheses by square brackets of lists. So I'll do router 1, router 2, switch 1, switch 2. And actually that'll do it. So if I do a type against devices, you'll see it's a tuple. If I print devices, it prints the whole thing. I can even call specific items the same way I would in a list. But what happens if I try and append to it? Let's go ahead and append firewall 1. Object has no attribute. Oh, should probably spell it right. But either way, it still errors out. Because once you declare a tuple, you cannot change the value of that tuple. So there's nothing I can do. I can't devices. Oh, I don't know. Call this one 4. And spot 4 equals firewall 1. Tuple object does not support item assignment because I cannot change it. I've already declared it. There's nothing I can do. I can still use length devices. And it still gives me the length, but I cannot actually change the value of a tuple. If this was a tuple of dictionary objects, I could change the value of the dictionary, but that would not be changing the value of the tuple. So it's just important that we cover them and that you know how to identify them, which is going to be with your parentheses here, and that's going to let you know that that's a tuple and it cannot be changed. Postman comes with a feature called Postman Environments. So environments are a collection of variables that you define. So they can be dynamic or hard set in the variable value. They are not required, but they are very useful when you start creating or testing multiple APIs against a similar platform with similar variables. Environment variables can be set or they can be dynamic with JavaScript code, which we will look at later. And then you call the variable in your API in the header or actually in the URI itself with double curly brackets and the name of the variable. Those double curly brackets you will also see later on in the course, and it is known as Jinja 2 formatting, although that is not necessary to know in particular for this. We will not get into the fine details of Jinja 2. It is important to point out that that is Jinja 2 formatting identified by double curly brackets. Postman offers us the ability to create environments. And what is an environment? Really, it is just a bunch of different variables that we store, and these variables may be used across multiple API requests or be associated to in a collection. So up here in the top right corner, we have our environment section. As you can see right now, I have no environment selected, but I do have some that I have either installed or created on my own. So right now with no environment selected, if I click this environment quick look button, you can see I have no active environment and no global variables. Here's some places where you can click to learn more about global variables and active environments. I'm going to go ahead and come down here and click the DNA Center Sandbox environment. And then if I click the environment quick look again, now you can see I have variables along with values for those variables. The variables that I have is the identifier for the Cisco DNA Center Always On Sandbox on the internet, the username, and the password for it. Note though, you really do not want to store usernames and passwords in clear text like this, but for a lab scenario, that is okay. And it gives me the initial value, what it was set to, and what its current value is. If I wanted to edit anything in here, I can just click edit. In here you can see I can add more variables, and then I could give them values. And then I would update it. Here's all my environments, so I can share these or download them so that I can export them or share them with other people. So that's one of the great things about environments is some of these I had shared with me from Cisco's DevNet. So I've selected the DNA Center Always On Sandbox, and I'm going to come over to my DNA Center API collection. And here you can see it is calling the variable DNA Center and the variable port. Under my quick look, you can see I have the variable DNA Center, or DNAC, set to sandboxdnac.cisco.com, and this is how I call the variable in my request. If I hover over it, you can see it shows me an E for environment, DNAC, and what the value is. Same goes for port, as it's specifying port 443. In the authorization section, I also call the variable username, which is linked to DevNet user. This is a post request because I am providing information such as the username and the password, so I am giving the API server information and expecting something in return. In my headers, you can see I have set authorization, and then here is the value that I set for authorization, which is a basic authorization value that I set from here. So now I'm going to go ahead and run this request, but before I do, I want to note that this is the first request where you need to actually use tests. So tests are written in JavaScript. However, it is not important that you understand JavaScript fully, but that you can read the code. So here you can see it sets variable data, and it is equal to parsing the response body of JSON, and then in here we are pulling the token from that parsed data variable, and it sets the environment variable token to that value. Our environment variable token is right there. You can see its current value. I haven't ran this one in a while, so it should change the token when we run it. So let's go ahead and run it and see what we get. It is finished running. You can see we get a status code 200 OK stating that it was successful. And here's the value that it returns, which is our generated token that we will use for further requests in later labs. If I come up and look at my environment quick look, you can see although it does start the same, it has in fact changed just a little bit. I had to verify some of those because it is so similar. But yes, you can see that it is now changed to a different value, and here's the token's new current value. If you visited Cisco DevNet yet, you will find that the most basic labs start to introduce you to Cisco DNA Center Always On Sandbox. So what is Cisco's DNA Center Always On Sandbox? It's probably one of my favorite tools on the internet, and what allowed me to actually start getting my experience in software-defined networking and API calls for a network engineer. It's a software-defined networking solution consisting of a controller and an application, and it's Cisco's SDN solution for the local area network, otherwise known as the LAN, which would include wireless devices as well. It's a real vendor SDN solution, so you could potentially see this on the job if that's the vendor that your organization chose to go with. The Always On Sandbox allows us to practice different API calls against something that you may actually see on the job and retrieve and put information in there as though you were actually on the job. If you continue on in DevNet, you'll see that they have further labs and information on not only the LAN side of the house for DNA Center, but also security with firepower and the data center with Cisco's ACI. It is open to the public internet and free, and Cisco DNA Center also offers a web interface. Deck of Cards API is another API server on the public internet, which is a great tool to practice scripting against an API. It is what it says it is. It's a virtual deck of cards, and you can define how many decks that you have, assign the cards that you draw to specific variables, allowing you to create games, use loops to actually create conditional matching, practice coding against a certain value, and make whatever game it is that you want, because you can actually draw real cards in a programmatic and API way. It's open source, so it's available on GitHub and anybody can contribute to it. And it's very flexible. I think that's what makes this such a great tool for practicing APIs, also in the fact that it's fun and you can create card games if you want, just by going over the rules of the game and converting that to a scripting language. Very briefly, I did want to go over Deck of Cards API, what it is, considering your lab calls for you to start interacting with it. So Deck of Cards API is just an open source API that's exposed to the internet, and the idea behind it is that anything you could do with a deck of cards, 2 decks of cards, however many you need, you can use this API to practice your scripting, API calling and pushing skills. So whatever game it is that you can think of, you can create in the scripting language of your choice and use this open source API to practice your API calls and your scripting skills. So in summary, we've looked at an introduction to Git. We've gone over the differences between Git and GitHub. We've covered variables and scripting, and it's very important that you understand some of these core theories before moving on. So practice, practice, practice is the key. We've gone over lists, dictionaries, and tuples in Python and how they can be used and their differences. We've looked at Postman environments and how we can use those environments to store our variables. We've covered Cisco DNA Center Always On Sandbox, which is available on the public internet and a great tool for testing APIs and scripting against a real lab network environment. We've gone over Deck of Cards API and how that can be a useful tool for practicing scripting, coding against another open source API server, and how it's fun because you can make your own card games out of it. And finally, we looked at a short demo of everything that we've covered. If you have any questions, please direct them towards the discussion board, because chances are, if you have that question, that someone in the class has the same question. Thank you very much, and I hope you enjoy this week's lab.